Hi, hello, high school 1A and B students. How are you? I hope good. Okay, so let's start our new lesson. Lesson will be mainly about slope and forces acting on the object on the slope. We will be talking about force components on the slope. Okay, but let's start with your homework. Thank you. A few people sent me your homework. Of course, not of all. It will be new rule or regulations starting now or next week. I will send you a message on Classroom. Okay, but let's check your homework. Be prepared to the lesson. I hope you have a pen, pencil, ruler, eventually calculator. So let's check your first exercise. So let's look. In this case, you have to find acceleration of the object. It's not too difficult. Acceleration of the object and friction of the object and force of friction. Okay, force of friction, acceleration of the object and force of tension. Force of friction is given. Okay, so first of all, you have to find acceleration. Acceleration is total force divided by total mass. So what with total force? Object, this system experiences three forces. Force of 40 newtons acting to the right and two frictional forces acting to the left. So acting to the right is positive, acting to the left is negative. 40 minus 20 is 20 newtons. Okay, and mass system contains two objects of masses m1 and m2. Each is equal to 4 kilograms. 4 and 4 is equal to 8 kilograms. So acceleration of the object is 20 newtons divided by 8 kilograms, which results in 2.5 meters per second squared. Yeah. Okay, so we have acceleration of the system. Now you have to focus on this. Okay, this mass experiences two forces. Force of friction acting to the left and tension acting to the right. Okay, so let's copy this. Two forces. Force of tension acting to the right and force of friction which slows down and acts to the left. Okay, mass is equal, of course, 4 kilograms, and we know that it accelerates to the right with acceleration 2.5 meters per second squared. Okay, so we can find total force. Total force acting is equal mass times acceleration, so 4 kilograms times acceleration, which is 2.5 meters per second squared, which means that this is 10 newtons. Okay, so we know that force of friction is equal to 10 newtons. We don't know tension, but we know that overall force, which is a result of tension acting to the right and friction acting to the left, equals to 10 newtons. We know that overall force must be equal to 10 newtons. Okay? So if overall force is a difference between tension and friction, tension acts to the right, so positive, friction acts to the left, so the negative, and we know that overall is 10 and friction is 10, then total force, the tension must be equal to 20 newtons, because 20 minus 10 gives 10. Okay, I hope you have something like this. If not, please make some correction. Okay. And second, your second homework were a little bit more advanced, but only a little bit more advanced with the balloon. Okay, balloon was attached. Okay, by two cables. Okay, each creates a tension, and we know that the balloon has a mass of 200 kilograms, and there is a buoyant force 2,500 of newtons. You have to find tension of each cable. Okay, so first of all, please focus on the three-body diagram. Forces acting on the balloon. Balloon experiences four forces. Okay, this is gravitational force acting down, buoyant force acting up, and two tensions which act along the cables. So tension 1 and tension 2. Is it clear? And balloon is stationary, is attached. Okay? Which means that all forces must be balanced. All forces must be balanced. Okay, and some forces are given. We know that buoyant force is 2,500 of newtons. And it's easy to find the gravitational force. Gravitational force is mass times gravitational acceleration, so 200 kilograms times 10, which gives 2000 newtons. Okay? So, we know that overall vertical force is equal to 500 newtons up, because buoyant force is bigger by 500 newtons times than gravitational force. So I'm going to create a little bit another diagram, okay, based on two tensions, Ft to the left and Ft to the right, okay, and only one force as a result of buoyant force acting up and the gravitational force acting down. So this force, let's name it up, is equal to 500 newtons. Okay? Because the difference between buoyant force 2,500 and the gravitational force 2000 is 500 newtons. Okay. So let's look. These forces must be balanced. These two tensions acting along the string must balance up force of 500 newtons. What does it mean? It means that each vertical component of each tension, this one and this one, must be equal to 250 newtons, because 250 plus 250 are able to balance this 500 newtons acting up. Is it clear? So finally we have something like this. I'm talking about this triangle. Okay? In this triangle we know that this is force of tension. Okay? Which can be split into two components. One acting down, let's name it Fd down, which is equal to 250 newtons. Again, 250 because we have two cables, and 2 times 250 gives 500. And this component, which is not important in this exercise. And we have one more important thing. This angle. This angle here is 30 degrees. So let's look. Practically, you have a triangle, okay, where this angle is equal to 30. This side, the height, is equal to 250, and you don't know this. Okay, property of triangle which is right angled and has 30 degrees is not the longest, it is 2 times bigger than the shortest. Okay, so what is the final answer? If the longest is a tension of the cable, then tension of the cable is equal to 500 newtons. Okay? So if tension of the angle is 500 newtons, then this component of the tension acting vertically down is equal to 250. 2 times 250 gives 500, which is able to balance difference between 2,500 and 2000 of newtons. Okay? Please check your calculations. If you have different result, please copy this to your notebook. Try to find your mistakes. Stop the video, of course, and you will be ready. Turn it again and go forward. Okay, so today's topic is friction. Today's topic is slope. Okay, and today we'll focus on the situation when object is placed on the slope and friction doesn't act, because to talk about slope with friction, you must be a little bit more experienced in the friction. Okay? So slope, you can write in the brackets, no friction. Okay, so let's imagine that you have inclined surface. Okay, height, this is our surface, and this is horizontal line. Okay, and usually in the case of slope, the angle of incline is given. Okay, and let's imagine that you have an object. Okay, of given mass. Yes, and this object, of course, slides down along the slope because there is no friction. You can imagine if you have inclined surface and you place something which with very small friction coefficient, like, I don't know, a piece of ice, yes, it will be sliding down. Or another, if you have a toy car or a ball, a sphere, it will be rolling, moving down the slope. Yes? Okay. First question is, how many forces act on the object placed on the friction? Okay, so of course the answer is two forces. Object of given mass experiences a gravitational force, which acts vertically downward, and there is also a normal reaction force. Okay, let me draw a line, which acts always perpendicularly to the slope, so along the line which is perpendicular. Okay, and what is the relation between these two forces? Okay, I've created this normal reaction Fn shorter than gravitational force. Why? Because let's look. An object placed on the slope moves always along the surface. Okay, so moves always along the line which is perpendicular to the normal reaction force, which means that overall force, yes, overall force, the net force, the resultant force, or the sum of normal reaction and gravitational force acts always in the direction of the slope. Okay? So let's look. If you will add these two forces, if you will add normal reaction force, okay, I'm creating the same again. This is our slope, and this is our line which is perpendicular to the slope. Between these two lines we have right angle. Okay, so when you will add normal reaction force, this one, which acts always perpendicular to the slope, and gravitational force, I hope you know how to add two vectors. You have to create a line, yes, which starts an arrow which starts at the end of previous vector. So if gravitational force acts vertically downwards, we have to create arrow vertically downward. So when you will add this normal reaction, this one, with gravitational force, with this one, you have to obtain force acting along the slope, which means that normal reaction must be perpendicular to the slope. Okay, and moreover, if you will focus on this triangle, I'm going to create this triangle bigger here. This is our normal reaction, this is our gravitation, and this is our resultant. Okay, and labels. This is normal reaction, this is gravitation, and this is overall force. Okay, then angle of inclined, this angle will be here. Okay, of course, normal reaction makes 90 degrees to the overall, but this angle is here. Okay? So let's look. We have a right angled triangle. And usually mass of the object is given. You will see that mass is not important, but let's assume that at this moment that mass is given. If you know angle, you can link these all lengths or sides of this triangle by trigonometry. Okay? So for students who didn't do trigonometry, so for HS1 students, HS1A, it will be something new. For HSB students, it will be revision. We have some functions in the right angled triangle. The names of specific ratios between specific sides. And if you have a triangle, right angled triangle like this, and you have specified angle like this, then the ratio between opposite, so F, and hypotenuse, so FG, is known as a sine of the angle, and the ratio between adjacent, Fn, and the longest hypotenuse, Fg, is known as a cosine of the angle. And what is important here? If you have calculator and you know angle, you can calculate this ratio. Calculator knows what is the sine of any angle and what is the cosine of any angle. Okay? Example, if you have calculator and you write sine of 30 degrees, then your calculator will respond half. Because the ratio between F, this one, and Fg, this one, if this angle is 30, is equal to half. So calculator knows how to calculate this for any angle. Is it clear? Okay, please copy this. On next slide I give you some details. Okay, so next slide. I need this. Okay, and sine and cosine. Okay, so I wrote that sine of the angle is equal to F over Fg, and cosine of the angle is equal to Fn over Fg. Okay, so let's continue. Force is equal Fg times sine of the angle. Yes? Okay, so this overall force acting on the object placed on the slope, if friction doesn't exist, is equal to gravitational force acting on the object times sine of the angle. Of course, force by second Newton's law of motion can be written as mass times acceleration, and the gravitational force mass times gravitational acceleration. You see that the mass is cancelled. And here you have equation for acceleration of the object placed on the slope. It is gravitational acceleration multiplied by sine of the angle which slope makes with horizontal. And in similar way we can calculate normal reaction force. Normal reaction is Fg times cosine of the angle. So normal reaction is equal mg times cosine of the angle. Is it clear? So normal reaction force can be calculated by using this. Mass of the object times gravitational acceleration times cosine of the angle. Okay? Please copy this. On next slide I'm going to conclude this topic and give you some easy calculations. Okay, so to sum up, if you have object which is placed on the slope, okay, which makes an angle alpha with the horizontal, then this object experiences two forces. Gravitational force acting vertically downwards and normal reaction force from the surface which acts perpendicular to the surface. These two forces add together result in an overall force, F, which acts down the slope. Is it clear? Okay, and we derived few equations. Of course, gravitational force is always given by m times g. Okay? We derived equation for force, overall force acting on the object, and it was mg times sine of the angle. If angle is bigger, then sine is bigger, and overall is bigger, which means that object accelerates more. If angle is smaller, then sine is smaller, which means that f is smaller, and object accelerates less. Okay? We derived also equation for normal force. It is Fg times cosine of the angle. Remember, Fg is given by m times g. And we derived expression for acceleration is g times sine of the angle. Okay? So, by using this simple method, you can solve all problems related with slope. Okay? But watch out, you have something new here, trigonometry. Use calculator to find trigonometrical function of an angle, and remember you have to, because usually in scientific calculators, yes, the default option for default unit for angle is radian. So you have to convert it from radian to degrees. So you have to find in setup of your calculator option which changes, okay, unit for degree. Then you can solve any problem by using calculator. Is it clear? Okay. So task to you. Equations are given. So task to you in the form of the homework. You have to find gravitational force, overall force, acceleration and normal reaction force acting on the object of mass of 2 kilograms placed on the slope which makes 30 degrees to the horizontal. Is it clear? So practically you have all equations given here. All you have to do is to use calculator and find this. Is it clear? Okay. So this is your homework. I expect your homework in 6 days in your Google Classroom. You can write in the post just results. Yes, Fg equals blah 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 newtons, F equals blah 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 newtons, A equals blah 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 meters per second squared, and Fn equals blah 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 newtons. You can attach your answer in the form of post below this topic, and in this exercise you can use G, not 9.81 but 10 meters per second squared. Okay? So learn physics, stay at home, and see you next time. Thank you for watching. Bye.